Hey, okay, sorry. Okay. Hello, good afternoon. Well, welcome to the second lectures of the ACM ICPC training series conducted in Faculty of Computer Science, Ministry of Malaya. I'm Chi San Liu, and today we'll continue to the next challenge in the USACO. Just for information, we are all the while using this application, this gateway provided by the, okay, let me share the screen. We're using this gateway provided for the user, a computing Olympiad training by the United States. And so far we have covered up to sections greedy gift givers last week. So today we will continue to the next problems, which is the Friday the 13th. Okay, let us move on here. Well, this week seems like we have a very interesting problem to solve. This is about the calculating how many, when is the 13th of every month fall? Either is it on the Monday, Tuesday, Wednesday, or the rest of the week. And what we are requested to do here is given an n positive integer number where n will not exceed 400. We have to calculate what is the frequencies of 13 falling on each day of the week. For instance, what we have here is, so if let's say we are calculating from 1900 until 1919, okay, so the sample output will be, there will be 36 days where the Friday, the 13th of the month will be falls on Saturday, and 33 days where it will falls on Sunday, and vice versa for the rest of the day. Okay, so this is roughly the challenge that we are going to solve. And well, we also has been given some. Yep, I saw another new members joining. Okay. Yep. So now what are we supposed to solve? Try to calculate the frequencies of 13th of each month on each days of the week. And we're given some of the hints over here. Okay, like for instance, the January 1, 19,000 was on the Monday. Okay, sorry, 1900 was on Monday. And then there are 30 days during September, April, June, and November. And the rest of it had 31 days, except for February. And I think what makes it interesting over here is the calculations of leap years. Because for February, only leap years, there are 29 days, the rest are 28 days. And I think this is a trap if you are not very careful over here. So every year, evenly divisible by 4 is a leap year. Okay, and for the millennium year, it should be divisible by 400. So these are all the clear informations over here. And well, I think we have all the informations needed here. Of course, you're not allowed to use any built-in date function. Well, no worry, not a big deal over here. So roughly, how are we going to solve this problem? So we know, first thing, January 1st, 1900 was on Monday, which means that the 13th of the month, January 1900, should be on 1, 2, 3. Is it a Thursday? Yeah, it should be on a Thursday. Okay. So and then what is the that if you continue to calculate adding 31 days until the end of the month, then you will calculate the February actually is fall on if I'm not mistaken, Tuesday or Wednesday. We just add 31 days to the calendars that we should know. So let me do this simple calculations. Okay. Let me share my screen. Give me a second. Okay, which means if let's say this is we have the Okay, if you try to visualize the problem, okay, which I always recommend you to do. So if the first day is here of the month is a Monday, right? So this will be the Tuesday, this will be the Thursday for the 4th, and then 6th, the 7th, the 8th, the 9th, oops, okay, maybe not a very good font I have selected. Let me go to Korea New. Okay, this is more like it. Okay. Okay. Sorry about this. Not very good at this. Try to visualize it for you all. So Sunday, and then 8, 9, 10, 11, 12, and 13. Oh, sorry. For the first 13, it should fall on the Saturday. Okay, so this is for the month January 1900. Okay, yep. So how we actually get for the second month? Well, you can look at the calendar, but well, we can just do a very simple task. So actually, you can add another 7 days, 7 days. Then you should figure out. Actually, it's not difficult to find when will be on the first 1, 2, 3. So actually now we are entering February, and then if you continue, okay, then you'll get the ideas. Actually, for the second month, it should fall on Tuesday for the 13th. So this program asks us to calculate where actually the 13th fall on each month, right? So this is the problems you're going to solve. And remember the catch: not every February has 29 days. It's only on the leap years. So we should take this into the calculation. So actually for us, it's not very difficult to solve this problem, because we know that for the for the January month, there will be 31 days. So we just add another 31 days into here, then you can calculate where will be the next 13, right? Okay, so we can do for the do the similar things for all the month. So what I will try to do now is I will try to create 2 arrays. Okay, 2 arrays. One array is for the leap years, and the other array is for the normal year. Then I will keep the date. I will try to keep the numbers of days for each month. So for the leap year, for a normal year, it will be 31 for the January, and then 28 for the February, 31 for the March, and 30 for the April. The May should be 31, and then 30, and then 31, and then okay, July, and then this is August. September, October, November, and December. Right. So for the leap year, so it should be the same, except for February, they are altogether 29 days. Okay, using this approach, I can easily add the number of days for each month into the calculations without worry about is it 31 or 30 or 29 days. Okay, so this is the 2 arrays I'm going to use. So this is to read the number of days. Sorry, the number of days for each month. Okay, so what I want to do is, because I'm going to count the frequency where the 13th will fall on which day, so I have to keep track of how many days. So I have to keep track how many times 13th falls on each day of the week. So what I will do is I will create the frequency. I just call it a sum, and definitely it will be 7 days. So, and then the first one will represent Monday, the second will represent Tuesday, and so on and so forth. And normally the calculations, as I started here, I will start with Sunday. Well, so I will start with Sunday then. Okay, so this is started from Sunday, and then followed by Monday, and then blah blah blah, and then the last day will be on the Saturday. Okay, so this is roughly what structures I need to hold all the data. Okay, so well, now we have the day. We know the day number of days for each month. We have the arrays to store to keep track of the frequency, and then what we need to have next. Whether we need to determine whether the given year is it a leap year or not a leap year. Okay, so we must have a method here to return. If it is a leap year, then it will return different result. Okay, so now what we should do now is write a function, write a simple method. I have another members joining in. Kazan, welcome. So we are halfway solving the problems Friday the 13th of the USA Computing Olympiad. Okay, just for your information, for those just joined the section, this is the problems that we are solving right now. Okay. Yep. Okay. Now we get back to our solutions. Okay. We are trying to figure out what are the informations given, and then what is our strategy to solve it. And then we figure out actually we just use two simple array. One is keep track of the numbers of days for each month, and one for the each month of the year, including normal year and a leap year. Okay, and then we keep the frequencies where the 13th falls on each day of the week, starting from Sunday, Monday until Saturday. And then we need to write a very simple method to find out whether a given year is a leap year or not. Right? So it has to be given in the text. Let me see. Every year evenly divisible by 4 is a leap year, except if it is a century year. Century year means 1700, 1800, 1900, and 2100. So this, which means if, okay, so it's leap year if the year is divisible by 4. Divisible by 4 means if I get the year modulus by 4, it should return 0, right? Okay, if it is divisible by 4 and it is not a century year, okay? Century year is those can divisible by 100. So if it is not divisible by 100, oops, where if you get the modulus, this shouldn't be 0. Okay, then this is a leap year, right? Or what is the second possibility? If the year itself is divisible by 400, and then definitely this is a leap year. So these are the two conditions, right? So the first condition is if it is divisible by 4 and it is not a century year, or if it is divisible by 400. So it means our function is quite simple, right? Okay, with all this information, now we should go to write our program. Okay, let me switch to my Eclipse now. Sorry, open up too many screens now. I'm a little bit confused. Okay, this is the Eclipse. Okay, remember this is a standard template for you to answer all the questions in the USACO. Okay, standard template where you have your ID. So if you haven't created an account on the USACO gateway, please do so. And for all the answers you submit, you have to have this 3 information. Okay, the first is your ID. and then second is the program. So this program is written there, the program name is Friday. Okay, so once again, let me show you the program page. Okay, so the program, this is Friday, the program name. So this should be get into the command, and then second, the input file is Friday in, the output file is Friday out. Okay. Okay, now we go back to our program. Okay, so what we have here is this program should call Friday, and then the input is Friday in, and then the output is Friday out. Okay, normally for testing purposes, we just disable file IO first, and then we can do it locally. Okay, so what are we supposed to do now? Just now we have draft some of the ideas that we are going to solve it, how we're going to solve it. So let me bring them in. Okay, this was written, what we have written just now. Okay, all right. So first we will have the two arrays, one for the years, one for the leap year. Of course, this is what it should look like. And then, oh, this is a normal input when you have, this is to keep to store the input data. Okay, so for any given n, we will calculate the frequencies of the when the 13 falls on each month on the given years from starting from 1900, okay, to n. So what this is, this is will be another structures to hold the frequency. Okay, so and then we're supposed to write a very simple method. So what this method is supposed to do, this method should return a Boolean value, whether telling this but this a given year is a leap year or not a leap year. Okay, so sorry, I have a call over here. Yep, I muted. Okay, so how we do the calculations, we have the ideas over here. We can confirm it is a leap year under these two situations. Okay, under these two conditions, either it is divisible by 400 or it is divisible by 4 at the same time. It's not a century year. Then we can make conclusion that actually this is a leap year, right? Oops, sub is not happy over here. Is it because of I haven't completed? So otherwise, we should return false. Okay. Why there's an error? Oh, I think my mistake over here. Okay, is it better now? Oh. Okay, so let me check if. Oh, sorry, that's my mistake. I call it year and then I put a Y over here. And if year is okay, you should feel happy now, is it? Oh, sorry. This is our commanders now. So actually, all is like this. Are you happy? If not yet, sorry. Definitely not my day. Okay, the two situation, if it's divisible by 4 at the same time, it is not divisible by 100. Okay, or it is divisible by 400. Why is keep on complaining? Syntax error. Okay, let me see. I make a big mistake over here. Ish. I have everything inside my main class. That's a problem when you draft your you draft your solutions on the text pad, and then you try to migrate into the Eclipse. So well, this remind me, next time I will straight away use the Eclipse instead of using my text editor. Okay. Okay, this is more like it. Yep. Okay, well, you can do a very quick test, see whether your year function is it correct or not. Okay, so printf for any given year, and then I want to check whether is it a leap year. No, make it simple. If n is leap n, then we just print out yep, just what we want to do. Okay, otherwise okay, so if n is 1900, it is not a leap year. Okay, so if n is millennium, yes, it is. So well, the function is good. So now we should proceed. Now we should proceed to the main program. As we said just now, once we have read the number of integers in, then we want to start to calculate. Okay, try to fill up this information over here. Right, this is what we want to fill up. Okay, so obviously, and then we need to complete it in the for loop. So what this for loop will do, okay, this is the, okay, this is what we want to do. Okay, so for every year starting from 1900, and then for every month, we want to calculate what is the frequencies of 13th falls on each days of the week. Okay, so then we have to calculate for the month. So definitely months would be less than 12, and then plus, and then blah 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 blah. Yep, we have it. Okay, so we keep on increasing, try to sum, and then what is the words? Okay, aggregating or accumulating the days in this frequency. So this is what we want to add, right? Okay. So what is the first day of the year? So maybe what we want to do is create. So not first day of the first 13. Okay, so this is the day, the first 13 starting from this day. We want to do the calculation. Okay, and then we will try to sum it. But of course, if you look at here, 13, but here is only 7, right? So if we go back to our draft just now, let me see, where's our draft? Okay, this one. Yep. So we fill up the end of the week, and then we go down to the next week, right? So actually we can do this. We can easily get 13 is falls on Saturday. If here starting from here is 0, if the index is 0, this is 1, 2, 3, 4, 5, 6. We can easily get 13 if we get the modulus of 7. Right. Okay. So if you get 13 modulus 7, we should get 6. So it will fall on here. And then if it is on the 14 modulus 7, it will be 0. So it will falls on here. So this is how we actually can do a very quick calculation. Right. Okay. Now let us go back to our program. Okay. So now what we want to do next. Let me see. Okay. So don't forget to put a modulus 7 here. Yep, this look like it. Then of course, after we get the first 13th of the January 1900, we want to continue, right? We want to add the numbers of days so that we can go to the second month. And we already have this information over here. So what we need to do is, well, I will say I will try to, calling this the nice method that we have created just now. And then given this is the year, given the particular years, if the years is a leap years, and then we should return the day, we should add the numbers of day. If let's say it's a leap year, then we should add 31 so that we can get when is the date the second 13th will falls on, right? Okay, so of course this is what I want to do. If this is a leap year, use the leap year. Otherwise, sorry. Okay, otherwise we use the other array. Okay, so this is the information. Oops, I forget to create another variable here, right? Okay, so when the year should start from? The year should start from 1900 as specified in the questions. Okay. Yep. Say this is. Oops, sorry. I've used years. Oh, I cannot use years anymore. Just put it a Y then. Are you happy now? Okay. Yep. This is more like it. Okay. So very brief. What this simple loop will do, it will go through starting from 1900, and it depends on how many years you want to calculate. If its n is 19, then we will go for all the from 1900s to 1918. Okay, and then for each month we try to calculate whether the 13 is falls on which days of the week. And then of course after that we keep on just adding the numbers of the days for the particular months, we will get the following month. So if they keep on going, and then we can get the whole thing filled up. Okay, but of course don't forget we are just starting from the first year, and then we will stop it for this given date. So what we want to do is for every year we increase it, the counter. Okay, wait. Okay, so I think this is what it should look like. Yup. Well, now once we have calculated the array, the frequency is already calculated in this nested for loop. What we want to do is we want to print out. Okay, we want to print out the day. So what we want to do is we want to use a very simple for loop. And then, okay, so this will print out the day, and this is for the frequencies that we have calculated just now. Okay, let us try. Let me build the program. And so if let's say I just want to count for the first year, so this should be 113 falling on Monday, one on Sunday, one on Monday, one on Tuesday, one on Wednesday, one on Thursday, one on Friday. It doesn't look good. What's wrong? From 0 to... I'm sorry. There's 7 days a week. Huh. Yep, this is more like it. Okay, so this is the distribution for the first year, 1900. Oh, this is starting from Sunday, and the result requires us to start from Saturday. Okay, so not a big deal. What we want to do is we want to print starting from Saturday, and then Monday, and then Tuesday, Wednesday, Thursday, and Friday. Okay, so this is what it should look like. So we just change it so that you print Saturday first. Okay, so now our program is ready and input output's ready. So what I will do now is we should try to submit it. Okay, now go back to the website. Oops. Ding, 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 ding. Okay, this is my website. Choose the file and then send it in. Oops. Red means not good. What's wrong over here? Your program did not produce an answer that was judged as correct. We seem to have additional extra space over here. Okay, this will happen because of they are doing a simple string comparisons between the two files. So additional new line, additional space is considered a wrong answer. Okay, too bad we cannot get it correctly at first. Well, at least we know the problem. Okay, just a very simple tweak. So here, it will print an extra space for the last line. Well, then we do something like this. Is it possible? Okay, for the very last result, you won't print the space. Take out the space. Of course, now this one we have to reduce. It's no more 6, but now become 5. Right? Okay. Second attempt. Hopefully this time is correct. Let me share my screen. Okay, choose the file and then send it in. Data for run. Okay. Okay, the program stopped at 0.05 it used, and then let me see. Is it because I have a new line over here? Oh, okay. I forget one very important thing. Okay, the result. Okay, let us go back to the questions here. Okay, this is another very common mistake. Okay, first is I have extra space. Second is I didn't complete with a new line. Okay, so the answers here should have a new line. So now I go back to the program. Go back to the program. Okay, this will make the system happy. Okay, so we have 2 errors today. Both are on the format. Okay, in fact, we should try to avoid this. I guess after a few practice, we should be able to avoid this kind of problems. Okay, let me now go back to the submission. Okay, I guess this time should be correct. Then choose the file, training. Yep, that's it. Okay, so our error today, first, we have an extra space. Second, we didn't put a new line at the end of the program. Okay, so this is the result. Congratulations, we have accomplished this task. And now, and then this is the programs that we have written just now. Okay, well, I think that's it. That's it for today. Yep, I hope you enjoy how we solve the problems today. And there will be another sections after this. So stay with us. Thank you. Bye-bye.